Namaste, I am Shreyas from Electronics and Communication Engineering Department of Vivekananda College of Engineering and Technology. Today I am going to explain design and testing of bridge rectifier with and without filter. So first of all, what is a rectifier? Rectifier is a circuit which converts AC into a pulsating DC. So you can see here the setup. Here we are giving the input, that is AC, from the supply itself. We are taking that supply to the rectifier. Rectifier in the sense that they are taking it to the transformer. Transformer is where we have used center tap transformer. Here in this center tap transformer you can see 3 pins will be available. So this middle pin is for the center tap. So what is the advantage of using a center tap transformer is we can take it from here. But the thing is, in the bridge rectifier you need not use the center tap transformer. You can use any transformer here for taking the input purpose. So the input will be coming to the transformer. That transformer input will be the stepped down transformer we have used here. The input will be around 230 volt AC, and the input here what we are getting around 12 volt to 24 volt, that is depending on the center tap we have used. So here we are getting 12 volt. We are taking from positive to and middle of that center tap. So we are taking that value and we are giving it to the input of the rectifier. So here the circuit you can see. In this circuit, this is the transformer. We have used this transformer, and from there we have given the connection to the 4 different diodes. The difference between the center tap and bridge rectifier is here we are using 4 diodes, whereas in the center tap transformer we are using only 2 diodes. You can see the setup here. D1, D2, D3, D4 are connected in the bridge manner. You can see this in the bridge manner we have connected. So input we are taking from the center tap transformer side, that we are giving it to the input for this bridge, and in this bridge D1, for the D1 we have connected this one, and for the D4 we have connected the negative terminal. And what happens here, you can see, observe here. Once if it is AC only, the input what we are getting to the secondary of the transformer is AC itself. That AC is given to here, and you can observe during the positive half cycle of the AC, the current comes here and it flows through D3, because D3 is a forward biased path. So it flows here, and in the east path you can observe this flows through D4. So D3 and D4 are used for a positive half cycle, and for the path will be completed. And during the negative half cycle, what happens means D1 is forward biased. You can observe this D1 as a negative of the D1 we are connected to this during the negative of this one, and D1, and you can observe D2. So the path completes. So it acts as a bridge rectifier, and during both positive half cycle and during the negative half cycle, both the time it conducts. During the positive half cycle as well as during the negative half cycle, it conducts. And the output waveform you can observe in the CRO screen. You can observe the output waveform. Here we have used with filter and without filter. The difference between with filter and without filter is here. In the with filter, to the load we have connected capacitor. Across the load we have connected one capacitor, and here in the for easy purpose we have connected this one capacitor across the load. And that load you can observe here. See, this is the with the filter output waveform. Without filter means we have to remove this capacitor, and we can see here in this circuit I have shown here with the filter we have capacitor, you can observe here, and without filter, without capacitor, it is there. And the output waveform we are observing here on the CRO screen. So it is, we have switched on the this one transformer, and that input will be coming to the bridge path here, and the output will be the output what we are getting is a pulsating DC. It is not a pure DC. We are not getting the pure DC. We are getting the pulsating DC. So we have connected one capacitor so that we get a more smooth waveform in the output side. So you can observe here, and the values, everything, it is displayed on the CRO screen. You can observe here. V peak to peak is 6 volt. It is displayed, and VRMS it is displayed as 15.6 volt. Those things are I can have a formula to show this. VRMS equal to Vm by root 2. Yeah, that is very simple. What happens means the maximum value divided by root 2, that is Vm Vm by root 2 and Vm equal to root 2 into Vrms. That is what we have studied. And Vdc is 2 Vm by pi. That is also there. I can show the calculation part here. So what we have to do is we have taken 1 kilo ohm resistor as the load, and Vm we have noted as here we are getting the value of Vm. That Vm we have noted it here, and we have calculated Vrms equal to Vm by root 2. That's it. And Vdc equal to 2 Vm. Once if you get the value of Vm, it is directly taken from the CRO. 2 Vm by pi, and ripple factor also we have calculated, and efficiency is Vdc square by Vac square into percentage, that is into 100. So we get the efficiency. Here in this calculation we are getting the efficiency around 80%, and percentage of regulation is nothing but no load minus full load divided by full load into 100. If you do, we get percentage of regulation as well. And with the filter and without filter, it changes, the formula changes here. In the with the filter, you can see Vrms equal to with the filter, with capacitor filter, what happens means we are peak to peak divided by root 3 plus Vdc we have to add. That is in the with the capacitor filter, if you put it, we have to add, then only you get the correct value here. So the calculation part goes like that only. Vrms equal to Vm by root 2, 18.8 divided by root 2 they have done, and they got one value. And Vdc equal to same V2 Vm by pi, and eta equal to Vrms by Vdc whole square minus 1 square root, and eta we get around 80.9. And with the filter also the same calculation. I said about one change in the formula, then rest everything, all the calculations part, everything is similar to the with the capacitor also. I will show the waveform here. You can observe very clearly in the graph. You can observe this. See, this is the input waveform what we are getting after the transformer secondary. In the transformer secondary getting waveform is this one. This is what we call as a input waveform to the bridge rectifier, and this is the output waveform without filter. Without putting the capacitor, we get the output waveform like this. You can see here in the CRO, it is a very smoothed waveform. Why? Because we have connected capacitor here across the load. So we are getting the smoothed waveform. Without capacitor, you get the waveform like this. And you can observe this here. We have shown this one also. With filter, we have shown the waveform. With filter, we are getting like this. You can see it goes like this. You can observe this. This is the zoomed version of the same waveform you are seeing here. So you can observe the same waveform here. So this is about bridge rectifier. You can, once if you get the value of all these Vm, you can calculate all these different values regarding your bridge rectifier. Thank you.